In this video, I'm going to discuss some data security concepts um, and storage security, I should say, but data storage. So basically, security with data that we're going to store, um, in some storage media. So some of the ways that we store data, obviously, there's locally attached storage. That's I think one of the basic forms of storage that most of us are familiar with. For example, a hard drive in a server or a workstation or an SSD card, a SD card or something like that. But most of the time in our enterprise platforms and our data centers and things like that, we use other storage technologies. One of the simplest ones that you'll probably encounter is a SAN, which is like virtual storage, stands for Storage Area Network. Now you may also see the term NAS or Network Area Storage, which is a little different than a SAN. So a SAN is sort of a shared disk. It's like a shared platform for storage. But when you get access to storage, it becomes like a hard drive in your computer. So it appears almost as if it's local storage, but it's really being accessed over the network. And there's technologies like iSCSI and Fiber Channel that we use to mount that. But basically, it's a shared disk, but you control your own disk. NAS, on the other hand, is more like a shared drive in Windows. If you're familiar with how Windows works with the SMB protocol, that's more like a NAS. NASs can use technologies like SMB. They can also use the network file system, even something as simple as FTP and so forth. But we have those two techniques. Your book mostly talks about SANs, though, so I'll put that in the PowerPoint. And then there's big data. So big data is basically these very large shared data sets, and this is becoming all the rage in not just in network security, of course. Well, really network security because of these other trends, but this is becoming more common in data centers and in companies where they're trying to analyze data across many different organizational units or across many different applications. The idea is that you can start aggregating data. So I work a lot in the healthcare field, and we're starting to use big data in healthcare. In the old days, we had data that was isolated in different systems. So, if a patient had surgery, that was in one system. If the patient had lab work done, that would be in a different system. Maybe their radiology interpretations are in a different system. But all of that stuff put together gives you one clear picture of the patient's medical history. So an example of big data in healthcare is we're now trying to aggregate all of that data for doctors and do analysis across all that data and do studies across all that data and reveal more patterns or reveal more information about patients by looking at it in context with all these different things that are happening. The problem with that is in order for all that stuff to work with big data, it requires a lot of sharing access to that data and having central repositories to data, and that's one more vector of attack for our data. So that's certainly becoming a bigger issue for us. And then the cloud is another issue. Clouds are great. It's bringing down the price of storage considerably. You can outsource the storage of your data and your applications, for that matter, but you can outsource that and do it much cheaper. You can use Azure or Google Storage or AWS and things like that. But the question becomes with the cloud is who has control of the data. So that's certainly a security concern and one that we discuss, I think, in other courses as well. So as far as data, the number one thing we can do, the most important thing that we can do is make sure that we encrypt our data while it's at rest. So in this slide, I'm going to talk about data encryption at rest. So while it's stored on the disk. And the simplest way to do this for users and for server operators is to use full disk encryption. So it's completely transparent to the user or to the people who are operating the server. All they know is that they're storing data somewhere, but under the hood, that disk is encrypted. And the idea here is that if somebody were to take the disk out of the server or remove the disk from a workstation or a computer or what have you, or even a tablet, that it's encrypted so you wouldn't be able to do anything with that data. So that's one technique, is this full disk encryption. We can also encrypt individual databases or only encrypt certain columns in databases. So a lot of database engines have the ability to do encryption. Most of the major database engines like Oracle, MySQL, Microsoft SQL Server, PostgreSQL, and so forth, a lot of those have the ability to do encryption or to set encryption at the database level. And then taking it one step further down, you can encrypt individual files. The problem with encrypting individual files is a lot of times this is something controlled by the user of the application. So it's kind of one more thing that somebody might forget to do, which would open you up to yet another avenue of attack if somebody forgets to do that. So you have to have automated systems in place maybe to check for that. There's certainly more management involved with file level encryption, but it's another option that we have in the toolbox to do file level encryption. So you could encrypt individual files. One thing I should mention here is that a lot of the popular file systems do support encryption. Probably one of the most common file systems that we find in business and in most organizations is NTFS, which is used by Windows. And as of recording this, I am fairly certain that NTFS, while it does encrypt the data in the drive, if you're using SMB protocol to move a file from one server to another, it's actually decrypted to move it across the network. So that's certainly something to be aware of, that just because you turn on file level encryption doesn't mean that it's going to be encrypted when you send it to another computer or move it from one computer to another. It may not be encrypted once it's moved. It might be unencrypted, and then maybe encrypted on the other side, maybe not. There's really no way to be sure. And again, that exact same problem would also exist with full disk encryption. Even though it's encrypted in the disk locally, it may not be encrypted when it's copied to another machine. So certainly something to be aware of. We can also use tools and utilities to encrypt removable media. Mobile devices can be encrypted. I think almost all mobile devices now, if you have an Android device or an Apple device, most of them now encrypt the data. That way, if somebody steals the mobile device, the data will be encrypted. So that's certainly useful. In the old days, we had to worry about that stuff. So when you're doing full disk encryption, so if you are going to use full disk encryption, the question becomes, what is the key for the encryption? If you're using something like NTFS for encryption, it's the user account is the key for the encryption. It's all stored with the user account. But with hardware-based encryption, you have to have, there's one option is the TPM or Trusted Platform module. And this is a physical key that's attached that provides the encryption key. So that could be a USB drive, for example, might have the encryption key. Of course, most people don't want to do that, so most modern hardware comes with a TPM module that is a piece of hardware inside the computer, so you're not worrying about losing a USB stick or something like that, but you can typically back them up to a USB stick. The other example is a hardware security module, which is very similar, but but not something like BitLocker, which is proprietary to Windows. So then the USBs and hard drives typically can also have hardware-based encryption. All right, so if we are going to secure data, as I said before, we're worried about data in transit, which is encrypting the data as it's being transferred through the network. So we want to make sure we have some network encryption, and we're going to talk about that later in the course. Or in other videos, we may discuss that. We also want to encrypt data at rest, which I just previously discussed. And another one that a lot of people forget about is data in use, and I talk about this in application security as well. But data in use is data that's in memory, or while it's being processed, or in temp files and things like that. So there are secure coding techniques you can do to mitigate those risks. You can use protected memory. And now there's actually some interesting work being done right now for ephemeral encryption, where they're talking about encrypting data in memory and between an application and the memory. It's kind of interesting how it works, but it's certainly something you could look into. And I think we're going to start seeing, if the techniques that they're describing right now that are kind of in the early stages, that if it works, we might start seeing that as well. And basically, the way that's going to work is the data will be encrypted, and even though it's encrypted, so let's say you had two numbers that you wanted to multiply. When you encrypt those two numbers, they might be two completely different numbers, but then when the microprocessor multiplies them and sends the sum, when it sends the product back, you could unencrypt the product and it would be exactly the same as if the microprocessor multiplied the real numbers. So you're basically telling the microprocessor to work with a completely different set of data, but the way the encryption works, the answer is always correct when it's decrypted. It's kind of interesting math behind that. certainly something interesting that you could look into and see how that works. I might post some articles about that in the in Blackboard. Another tool that we have for data security is access control lists. So access control lists basically are lists that determine what resources can be accessed by users and groups. There are other videos that talk about access control more generically and some of the access models like Bell LaPadula and lattice-based and so forth and so on, and these different philosophies in access control. But using access control, we can configure who can access which data. So certainly it's something in our toolbox, and whether you're using Linux or Unix or Windows or Apple, it doesn't matter. They all have tools that allow you to do this. Probably the most common that we see in IT in most organizations is Active Directory with group policies and things like that, where you can use access control lists to control access to different types of files, and you can use some of the paradigms that we talk about in other lectures. So permissions and access control lists is certainly another tool. And then finally, we have some policies. So you can have data policies that can also help mitigate these vulnerabilities with data while it's being stored or in transit, and mostly while in storage. So one common concern is if you're going to get rid of a hardware device that has data on it, how do we prevent attackers from dumpster diving, which we talk about in social engineering and physical attacks? How do we prevent somebody from getting a hold of that drive or that old device and getting data off of it? And the thing about it, and I talk about this in this unit as well. We're going to talk about alternative environments, and alternative environments could be all kinds of devices. It's the Internet of Things. You may have heard that term, the Internet of Things. We're talking about printers and SCADA devices like thermostats and building control systems and all kinds of stuff. All of those things have hard drives. So it used to be that if we're throwing away a toaster oven, we didn't care because there couldn't be any data on a toaster oven. But now it seems like almost everything has a computer in it and could potentially have something on it that an attacker could use. So we want to make sure that anything that has data, that we're wiping that data. And wiping basically means permanently deleting the data. And there are lots of tools and utilities that you can use that will remove that data. There's certainly some that you can purchase, but you can do it yourself in Linux. So you can mount any device in Linux and use the dd command and do what's considered a DoD wipe. You can't see me putting the quotation marks up, but DoD wipe is basically just a standard for deleting data to make sure that it's been adequately deleted from a disk so it can't be recovered later on. But there are utilities you can use to do that, and there's also tools that are free available in almost any Unix or Linux system, or Mac for that matter. Mac also has the tools that you would need to do that. And if you're wondering what tool that is, take a look at the dd command, and there's ways that you can do exactly what the DoD wipe tells you to do, which is things like writing random data, zeros, writing it several times, and so forth and so on. Once you wipe a device, then the question becomes how to dispose of it. You want to ensure the data is removed before disposing, and wiping is one technique you can use to do that. With magnetic media, you can use degaussing, and some people go so far as completely destroying. They shred or they drill holes in the platters and so forth and so on. The other question becomes, how long do we keep data? And data retention comes down to two things: how long do we need to keep the data, and how long do we want to keep the data? And again, I work in healthcare, and a lot of times the law defines for healthcare providers how long the data has to be stored, how long they have to have that data readily available. And in most states, it's anywhere between 5 and 10 years for adult patients, and for children, it could be different, and for different types of specific ailments, it could be different. Like, where the uranium mines, they might make them keep it longer for different types of studies and so forth. But that retention, so number one, the first question is, how long are we required to keep the data? And then the second part is, and again, most of that's regulatory reasons. And then the second part is, do we want to keep the data when we're no longer required to keep it? So one of the things we think about is, what use does this data have to our organization? Is it important for us to keep it? And if there's really no reason to keep it, we get rid of it. If there's no regulatory reason to keep it, and there's also no business reason to keep that data on hand, then the best thing to do is to delete it. It's one less avenue of attack. and it's also one less place that we're storing data that somebody could get through discovery, which is something common that we do in healthcare. We remove data just so that it's not there if somebody wants to try to get it to use it against us. But in any event, retention is, again, two important questions. How long do we have to keep it, and how long do we want to keep it, or how long is it actually useful? And then we want to make sure that we set our retention policy somewhere inside that window. And finally, storage. We should have policies that define how the data is stored, and maybe even require encryption and specifically codify exactly what encryption type we're going to use or what technologies we're going to use for the encryption. There are other videos that you can watch that will explain more about encryption and some of the specific types of encryption we can use for both data at rest and data in transit. So in this slide presentation, we discussed data storage security, so some of the concerns we have with storing data and how to mitigate some of those.